Weird. It's always a big hit.
Great.
Okay, welcome to CS 228, Human-Computer Interaction. I'm Josh. If you're in the wrong room, now's the time to leave. No? Everyone's in the right place? Okay. First homework assignment, what can we do to make it cooler in here? Who knows? Wait a couple weeks, right? Okay. So you're hot, I'm hot, we'll do the best we can. Okay, I'm the instructor for this course. My office hours are the hour immediately following this class. My office is over in Farrell Hall, which is on the Trinity campus. So if you have a short question, you can walk back with me to Trinity campus. And if I haven't answered your question by then, we can hang out in Farrell and try and answer any questions that you have. What we're going to do today is I'm going to spend most of the day just going over the logistics and expectations. And if we make good time, we'll get to some of the content of the class. So a bit of housekeeping first. Teaching assistant is Chris Hutchinson, who's sitting in the back there. There's Chris. I put up his office and office hours on Blackboard, but they are...
I'm in Bodie 343, and it's going to be Fridays from 1 to 2.
Okay, so it's all up there on Blackboard. If you have any questions, try and bounce them off Chris first. If Chris can't answer them, I will try. Okay, obviously you figured out where we are and when, so that's easy enough. How many people have a laptop here that they're planning to use for this class? Who has a Mac? Who has a PC? Okay, that's fine. The stuff we're going to be working with is both Mac and PC and Linux, so there shouldn't be any problems. If in installing all the stuff that you're going to be using in this class, you have a problem getting it to work with your laptop, come and see Chris or myself, and we'll see if we can figure things out. Worst case scenario, obviously, is you're going to have to use computers in the computer lab, but we'll see how things go. Okay, so just a little bit of a taste of this course before we dive back into housekeeping. Why are you here? Human-computer interaction is going to probably be quite different from any other computer science classes that you've had, and we'll talk about why that's the case. But I try and use this slide and the next one to really motivate why this class is different from most other CS classes. As you can see from the slides here, this is my very brief and potted history of computers. What's changed over time? A lot has changed. What is a general trend you can see from the top left to the smartphone in the center? Size, okay. Screens. How so? How have screens changed?
First they didn't exist, and then they were big, and then they were small.
Okay. They didn't exist, they were big, they were small, and then?
Touchable.
Then they were touchable. So I taught this class for the first time in 2006. And when I started this class, I said, imagine that someday in the future you'll be able to actually interact with your screen just by touch, right? So 9 years ago, the HCI changes incredibly fast, which makes this a difficult class to teach, but also a lot of fun because it's hard to say where things are going to go, right? No one would argue that computers have changed fundamentally since the late 1940s. And because computers have changed, the way that we interact with computers has completely changed, right? The way that people are interacting with the computer in the top left there is very different from how you interact with your smartphone today. So one of the main things I hope you take away from this class is as we start to continue to fill in this picture, you're able to think about as new technologies are deployed, how is that going to change the way that people interact with those technologies? And how can you design those interactive systems to take advantage of those changes in interaction? Okay, so that's the present. Here's a little bit of this filled in about where things may go in the future. We're going to focus quite a bit on this in this course on this little device here, and I have one here. This is the Leap Motion device. And at the end of class, I'm going to leave 10 minutes, and you're each going to get one, and we'll sign them out. You'll have them for the class. We're going to do this like a rental car agency. So you'll sign out your Leap Motion device, and then you'll bring it back at the end of the class, hopefully in one piece. Of course, I wanted to do a live demo of the Leap Motion, but this being the beginning of the semester, nothing seems to be working. So I can't give you a live demo, but I will show you a video of this in action. Okay. If I was able to run the demo, this is what you would have seen. The Leap Motion, as you can see, is a hands-free device here. And at every 100th of a second, the Leap Motion device is capturing the X, Y, and Z coordinates of all of the joints in all of your fingers, plus the orientation of your palm. First thing you're going to be doing when you take the Leap Motion out of the box is basically running this, this precompiled demo. Inside this device are two infrared cameras. So like the two cameras in your skull, because it's got two cameras, it can infer depth. So that's how you get X and Y plus Z. So you're going to be working with this Leap Motion device throughout the semester, and we'll talk about that in a little more detail in a moment. Okay, so as I mentioned, we're going to be spending a lot of time in this class thinking about how, as computers change, the way in which we interact with these things changes. How does your thinking about interacting with this Leap Motion device change your thinking about how you would interact with it compared to interacting with your touch phone? What are some of the changes in the interaction that are going to be caused by this device? Obviously, you're not touching the screen. Yep. There's not tactile feedback, right? So on some touch screens, you can get pressure or the amount of cross-section of the pad of your finger that's on the screen. You don't have that here. So there's some immediate physical things that are different, right? You're not touching the screen, but you're going to see over and over again in this class, when we start by thinking about physical interactions, that's going to push backward and backward and outward to cultural changes, social changes, much more large-scale changes. So we're going to be using this Leap Motion device in this class to create some educational software to teach people how to learn American Sign Language, or ASL. That's what you're going to be doing in this class. What are some of the challenges that are going to come up along the way? So someone places their hand over the Leap Motion device and they try or they fail to sign numbers and letters from ASL. What sorts of repercussions are going to happen because of this physical interaction?
Maybe sensitivity.
Sensitivity, how so?
Like the program needs to have the right sensitivity so that it's not registering false hand signs, or it's not so accurate that when you have to be very rigid about your hand sign.
Absolutely. And how would the user ever know what this sensitivity is, right? You can set the...
Shouldn't need to.
That's it, exactly, right? So that's another part of this course we're going to talk about, right? Hiding all of the things that the user does not need to know. You need to know it, right? You need to think about these kinds of things, build them in, and hide them from the user, right? So physical interaction, then there's sort of sensor motor things, like how sensitive it is to the actual sign that you're making. Let's push further back. What are some other repercussions that this might have?
Should be gamified in some way so that it's enjoyable to use.
Okay, right, so we're going to see quite a bit of cognitive psychology in this class and incentivization. Why should someone bother using your ASL educational software rather than someone else's, right? Might gamification make the difference? And we'll talk about that. Okay, some people may be incentivized by the fact that it's a game. Some people may be disincentivized since it's a game, right? So if you gamify it, you might be including people who like to play video games, but unbeknownst to you, you may be turning off some sections of your demographic because they're not really interested in games. It's another thing we're going to talk about in this class, which is implicit exclusion. The decisions you make in creating an interface for something like Leap Motion, you may be including some members of your demographic and excluding others. So people that don't like video games might be excluded from this. Who else might you implicitly marginalize by creating a software like we've been talking about? Who else might have a harder, easier time working with this device or using it to learn ASL?
People with disabilities, or
Somebody with disabilities, why?
because they can't make the hand motions, for example.
Absolutely. So we're going to talk a lot in this course about all the physical and cognitive ways that people differ. Some people are better at some things than others. And depending on the design decisions you make, you may be excluding people that are unable to make a sign, or they may have some motor impairment where they have a slight tremor, right? Leap motion does not like tremor, as you'll figure out soon enough. Okay, so let's keep going. So we're developing, you'll be developing this educational software throughout this semester. You're thinking about all of these issues. You have a prototype. You try it out with some of your friends. It works great with some of them and not so great with others. For some, it easily recognizes whether they performed the right sign or not. Other cases, Leap Motion says, I don't know what this person is doing. Why might that occur, aside from disabilities or motor impairments? People have different hand sizes, right? So everybody hold up your hand. Let's see how we differ in this class. Okay, so by the end of this course, you're going to be calibrating your system to work for all the hand sizes that you just saw. What else might differ that matters for this kind of device? It's related to hand size. Yep. Could be, right? So there might be other anatomical considerations. Is there something other than anatomy we need to take into account here?
Left or right?
Thank you very much. Are there any lefties in this class? More than one. That's good. When we did this last year, we had one lefty, and we really picked on her, unfortunately. She had to provide us with a lot more training data than everyone else did, right? Okay, so again, we'll get more into the Leap Motion device, but that's just to give you a taste for the kinds of things that matter in HCI, right? We haven't spent any time talking about what language you're going to code this up in, what platforms it's going to be available in. That's not important to HCI. It's the interaction between the interface and the person, right? We're going to try and think about people in all the different ways that they differ and how that may or may not matter for the kinds of things that we're doing. Okay, so you should all recognize this one as well. We'll spend some time talking about different kinds of technology. We'll talk a little bit about Google Glass. Most of you already probably wear your smartphones all the time, but what happens when your smartphone is right here looking in the same direction that you are, right? You think the Leap Motion device changes the way we interact with devices? Imagine if some people or a lot of people are walking around with Google Glasses, right? It's going to be interesting to see what happens. Towards the end of the class, we're going to talk about interactive systems that don't sit on the skin, but under the skin. So cybernetic implants are already a reality. This cartoon here, ironically, is an old figure now of a cochlear implant. This is for someone that has damage to their inner ear. Imagine you're trying to write some software to help someone with a cybernetic implant see better, hear better, move better, and so on, right? Again, you have a pretty exotic feedback loop now between the interactive system, the piece of technology, and the person that's using it. Picture in the bottom is a robot hand. My research interests, my research focus is in robotics, so I've managed to shoehorn some robots into this class. We'll talk about robots a little bit. That interactive technology is not here yet, although we do have drones now. How is our interaction with technology going to change when we have interactive technology that's out there in the physical world? Okay. So just to switch gears again now and back to housekeeping matters for a moment. Everything for the course is going to be administered through Blackboard. An interesting interactive system in and of its own right. Okay, so I sent around a group email. That was the first and last email I'll send around for this class. Everything will be posted as announcements in the Blackboard site. So if you're not sure what we're doing today or this week, go check out Blackboard. I just want to walk briefly through the syllabus, which you can find here on Blackboard. That does not show up very well. Okay, good enough. Okay, so the little blurb for the course, I'm just going to go through this very quickly so we're all on the same page. We're going to talk about user interfaces or interactive systems, how to design them, how to implement them, and how to evaluate them. Once you have a system, how do you know whether you're including or excluding different kinds of people? We're going to start with pretty familiar interactive systems like web pages, and we're going to march through this course from those simple, familiar user interfaces through increasingly exotic user interfaces. Topics will include interface designs. We're going to spend a lot of time talking about design, human factors, so you have a human in the loop. We have to think carefully about how people tend to use technology, what their expectations are of that. That will take us into a discussion of psychology. How do people interact with other people, with their physical environment, with technological artifacts? Everyone has expectations when they interact with things in the real world. We want to make sure to serve those interactions, those expectations, rather than break them. We'll talk a little bit about embedded devices and robotics and wearable technology. And this course does include a significant project using Leap Motion, which we'll talk about in a moment. Okay, so what do I hope you'll get out of this course? Again, to understand why HCI is unique and important in computer science as a whole. So understanding the nature of design as it relates to interactive systems. So you're going to be designing software for the Leap Motion device and thinking not just about how to make sure the software is correct, but what kind of user experience are you creating for someone that uses your software with Leap Motion. Okay. Sounds easy, but hopefully through this little exercise we just went through, there are a large number of subtle things that are often missed in interactive design. So you're going to get a lot of practice thinking ahead and trying to catch those subtleties before you find them in beta or full deployment. Okay. Obviously, because of the project, you'll be able to gain a lot of practical experience with creating interactive systems. And we're going to try and think ahead a little bit, right? As I mentioned, this class changes very fast. Where might things go beyond Leap Motion and Google Glass and the next generation of smartphones? Can you get ahead of the curve and think intelligently about what's coming next? Okay. Required textbook for the class is Designing the User Interface. The assigned reading is from the 5th edition. If you get your hands on a copy that is other than the 5th edition, that's fine. You'll just have to figure out which sections from the book were referred to and look them up in your own version. I don't think there's too much of a difference between the different editions. I tend not to stock the book in the bookstore because you all probably know how to find a copy of this book for less than the bookstore would offer it. So however you want to go about doing it, find a copy of the textbook. I'll also put a version on loan in the library. Some of the classes, I'll draw supplemental readings from this book, which I co-authored with my PhD advisor. I don't expect you to purchase a copy of this book. Because of the wonders of modern publishing, for every book that's sold, I make a grand total of $1. So if I successfully convince all of you to buy a copy of my book, I'll make a grand total of $39. So no need to buy it. I'll put all of the supplemental readings on Blackboard. However, if you do want to read it, please go ahead and do so. Okay. Versions of the lecture slides are posted online before class. It doesn't matter to me whether you follow along with the slides electronically or if you print them out and bring them to class. Either way you do it, I want to see you annotating the slides. People that do well in this class have a copy of the slides and they annotate them as we go. You don't need to annotate today because we're just going through housekeeping issues. Okay. At the end of every class, including this class, there'll be an online multiple choice question on Blackboard, which you need to complete by midnight tonight. It's usually 1 or 2 questions, and if you came to class and you did a little bit of the reading, you'll be just fine. So the multiple choice quizzes are just there to make sure that you keep up with the readings and that you come to class. Okay. Useful software. You're going to be using Python to program Leap Motion. Who has programmed in Python before? Who has not programmed in Python before? A couple people. Okay, that's fine. If you haven't, we'll talk about that in a moment. You're going to be using Python. You're going to be using a number of libraries. Numerical Python or NumPy. Matplotlib is a way to draw graphics in Python. And scikit-learn is a machine learning add-on for Python. We're going to be using these 3 packages. You don't need to learn them now, but if you find you have some spare time and you're not familiar with these packages, you might want to try them out. Okay, pause for a moment. Any questions so far? Okay, assessment for the class. 5% is participation. So every day I will bring in a very high-tech sign-in sheet. Just write your name on there and pass it along to the next person. I usually forget to collect this sheet of paper at the end of class. So whoever has it last, make sure I get it. If you come in a few minutes late, that's no problem. Just make sure to come up and sign it before you leave for the day. If you miss 3 or less classes, you'll get the 5% participation grade. If you find that you're missing more than 3 classes, come and see me and let me know why. Okay. So I mentioned class homework. So for the first 30 classes, there'll be a 1 or 2 question quiz that's due the night of that lecture. Each one is worth 1%. Okay, so the deliverables and the final project go together. So there's going to be 10 programming I'm sorry, do you have a question? No, just exercise. Okay. There are 10 weekly deliverables, 10 programming projects for the Leap Motion device. These are cumulative. So students that get into trouble in my class are the ones that miss one of the deliverables, and then the next week you've got to do last week's deliverable plus this week's deliverable. So try not to fall behind because they're cumulative. They're due each week. We'll talk about those in a moment. Each one is worth 5%. And then once you've done, in these first 10 or 11 weeks, when we've done these first 10 programming projects, at the end, you'll have an interactive system that allows your Leap Motion device to recognize the first 10 digits of the ASL language, hopefully for everybody's hand size, as well as for the lefties that are in this class. We're going to combine data from everyone in the class into one data set. Hopefully Leap Motion will be able to recognize all of you signing the first 10 digits of the ASL, Once you have that system at the end of 11 weeks, you have the remainder of the semester to turn that piece of software into an educational system that teaches the first 10 digits of ASL. If you want to gamify the system, you can. It's up to you to figure out how to expand that basic system. Okay. There is no midterm or final exam for this class. Some of you may be happy about that. Some of you may be not so happy about that. Any questions about the assessment? Okay. Students taking the course for graduate credit will have to do a little bit more work. I know there's a couple grad students here. Hands up if you're a grad student. Just these two, okay, who I know. We'll talk about that later. That's fine. Late policy, so if you submit one of the programming projects or you take the quiz 1 day late, we'll dock 25%. If you take it 2 days late, we'll dock 50%. If you're more than 2 days late, no need to submit. Cooperation, this one's always a little tricky. You're going to be working on your own, developing your own system. I'm happy if you want to collaborate and sort of learn a little bit from each other, but at the end, I'm going to want to see one educational software system from each student. Okay, use your judgment on that one. I mentioned class participation already. If you miss 3 or less classes, you're fine. If you're missing more, let me know. If there are any students with exceptional needs or access students, come and talk to me and we can make accommodations. All right? Okay. All right, so let's talk a little bit more about this final project. Okay, as I mentioned, we're going to be creating some software to teach American Sign Language, and let's see here. What have I not mentioned? Right, we're going to you're going to get your own controller. We're going to sign them out at the end of the course. A mention about the Leap Motion devices. I'm going to leave 10 minutes at the end of class today, so you can all sign one out. At last count, I had 40 students in this class, and I only have 35 Leap Motion devices. So if there are people in this class that know one another, if I could ask you to double up and share a Leap Motion device for probably the first week. I imagine we won't stay at 40 students. We'll see how we do. So if you're willing to share, please do, and just let me know when we sign out Leap Motion devices. Okay, I already mentioned Python. The first week when you're installing Python, installing the Leap Motion software and some of these Python libraries, we're going to have a lot of installation headaches. I know this is going to happen. The easiest way to deal with this is usually to download Canopy, which is a Python. It includes Python and all the libraries you're going to use in this class. So if you don't have Python installed on your machine, start with Canopy. If you're having problems installing the various libraries and you get stuck, try Canopy. It's free, works for all platforms. You should be okay. Chris is going to hate me for saying this, but if you have any installation problems and you can't figure them out, go and see Chris first. It's going to have a fun start to the semester here. Okay. Because of all of these installation headaches, I've set aside the first 2 weeks for the first deliverable. So there's 10 of these deliverables. So deliverable 1 will be due 2 weeks from now, and we'll talk about that. This also provides some breathing room for those of you that that you're not familiar with Python. If you haven't programmed in Python before, there's a link in the PDF here to an online Python tutorial. If you work your way through sections 1 through 9 inclusive, that should give you enough of Python for this class. Let's see, you might also want to learn a little bit about ASL if you don't know about that. Let's see. In the first deliverable here, like in many of the deliverables, you're not going to be ever submitting any code to Chris or myself. The thing that you're going to be handing in, the deliverable of the deliverables, is a pointer to a YouTube video. So what you're going to be doing throughout this first deliverable is capturing 3 short videos, and I showed you the first of the 3. So the first one is just you showing me your hand waving over your Leap Motion device, and the standard demo capturing that data and visualizing it in the background. You should be able to create that video within about 5 minutes. So most things in this class are going to be assessed based on these short videos that demonstrate you've implemented what you need to implement. So the basic procedure is you follow along the instructions for the deliverable, you get your code up and running, you wave your hand over Leap Motion, everything works. You grab your phone, this can be a little difficult to do, capture your hand and Leap Motion in the screen. If you have a friend, get them to shoot a little bit of video on your phone. Upload the video to YouTube. If there is more than 1 video for a deliverable, which there is for the first deliverable, there's 3, stitch those 3 videos together into a playlist. Go to Blackboard and you'll find an assignment for 2 weeks from now. The only thing you're submitting in Blackboard is a URL that points to that YouTube playlist. Chris will get that, he'll watch your videos, and he'll assign you a grade in Blackboard. Sound good? Okay, pretty straightforward. Okay, so I'll just very quickly go through these 10 deliverables. So in the first one, obviously you're just demonstrating that you've got your Leap Motion working on your platform, and then you're going to be creating a very, very simple infinite loop in Python, and every pass through that loop in Python, it's going to grab information about your hand and draw something to the screen. So to begin with, we're just going to be drawing a small dot, and that dot is going to move around as your index finger moves around over the Leap Motion device. So we're starting by creating a very, very simple interactive system that runs forever, that captures data from the user, displays it back to the user, and around and around and around you go. Once you have that very simple loop working, the rest of this course is going to be just complicating that loop. You're going to be adding more and more functionality to that loop all the way up to your final project. So my advice to you is make sure in deliverable 1 that you understand what this loop is doing. Where is data being captured, at what time, how is it being processed, how is it being drawn to the screen. And as long as you understand that basic loop and you get confused in later deliverables, you can always go back to there and work your way forward. Okay. So that's the first 2 weeks. In the third week, in the second deliverable, I'm going to assign each of you a different ASL letter or number. We'll see how things go. And you're going to learn to sign your particular ASL letter or digit. And you're going to draw that gesture back in 3 dimensions. So in deliverable 1, there's just a moving dot that's moving along with your fingertip. Now you're going to be showing that you've captured all the information required to sign a single ASL letter or number. Deliverable 3, which is going to be in the fourth week, we're going to start to get into the machine learning part of this. So if you sign an ASL letter, there is a huge amount of data that Leap Motion is capturing as you sign that sign. And we're going to take that huge amount of data, and it's going to have to your computer is eventually going to have to predict, did you sign this letter or no recognizable letter. So in order to get the computer to do that, we're going to have to take that huge amount of data that comes from one single sign and compress it in such a way where we're throwing away all the information that the computer doesn't need and makes it easier for the computer to pick out the features or the pattern in that data that indicates that's the digit 0 or the digit 3 or the letter J or what have you. Okay. Deliverable 4 in the 5th week, once we've done some of this dimensionality reduction, once we sort of cleaned up the data that your Leap Motion device is getting back from signs, then we're going to start to use the scikit-learn machine learning component of Python, which is now going to try and learn, did the user just sign 0 or 2 or J or what have you. So far, so good? Okay. To get used to this. Okay. This is all on Blackboard if you're having a hard time reading this in the back. Okay. In the 6th week, you're going to create a data set comprised of you signing your ASL letter and you signing a different letter, and then making sure that your Python code can now distinguish between these two. So you're going to perform one sign, then perform another sign multiple times, give that data to your computer, and it's going to find a pattern that's common to these two groups, but different between the groups. Then you're going to go back in and perform one of the two signs, and it should correctly recognize that you signed that sign, right? So you're going to be demonstrating to yourself and to us that your machine learning algorithm is working and actually correctly recognizing the different signs. In the 7th week, we're going to take data from everyone and put it together in a common data set. And then all you need to do is rerun your machine learning algorithm. So now it's not learning from just the two signs that you signed, but all the different signs that everyone here signed. So at the end of that process, if we're lucky, we'll have a general algorithm that's able to recognize different ASL digits from people with hands of different sizes, and hopefully righties and lefties, if we're lucky. Okay. We'll get to deliverable 7 through 10 later. Okay. And then as I mentioned, after the 11th week, you're going to take this system and think about how would you incentivize someone to learn and stick with the system to learn as much ASL as possible. The assessment of your final project will be exactly that. You're going to demonstrate through some user testing, so find some friends or flatmates who are willing to act as guinea pigs for you. How long will they stick with the system, and how much ASL can they learn from your system given an hour? We'll see. We'll figure that out later. Okay. Any questions about assessment for the course, final project? Okay. Okay, just a little bit about expectations. It's pretty straightforward. What I expect from you is feedback. We're going to have a little bit more back and forth once we get through all the housekeeping matters. So if you have a question or a comment, please chime in. Common sense, regular, as I mentioned, not necessarily perfect attendance. There's a lot of hard work in this class. Hopefully Leap Motion is sufficiently sexy and the project is interesting enough that you'll put in some hard work in this class. As I mentioned, make sure you keep up with the cumulative programming assignments. As you can figure out from now, there's lots of opportunity in this class to be creative. I expect at the 200 level a lot of self-learning. If you don't know Python, go find an online Python tutorial and teach yourself. If you don't know Matplotlib, Google Matplotlib, learn how to use it, and so on. So do see Chris if you get stuck, but tell him that you tried to find information online first and you tried the tutorial and you're still confused, and we'll go from there. Okay. Positive attitude when working with me and others, pretty straightforward. Okay. Most importantly, what you cannot expect from me or Chris, help with buggy code. Don't bring us your laptop and say my code is crashing. We don't know why your code is crashing either, right? Help with learning a programming language, installing software. Again, you should all know how to do that by now. Okay. What you can expect from me, help with general programming questions. So there's specific aspects of Python like dictionaries that we're going to be working with. If you're still confused about the general idea, Chris or I would be happy to talk with you about that. Again, consult online resources first. Help with conceptual issues. We're going to talk about conceptual issues from lots of different sources in this class. HCI is very broad. It touches on psychology, social science, human anatomy, as we've mentioned, all sorts of things. We're going to draw a lot of concepts from a lot of different places, so I'm happy to go through some of those concepts with you after the fact. Okay. Help with interpersonal problems, again, come and see me, clarification about the projects. I'll come back to the projects probably at the beginning of every class, so if you've so dive into the deliverables as soon as they're assigned, and if you get stuck, ask a question at the beginning of class, and maybe we can resolve it for everyone. Okay. I'm going to emphasize in this class concepts rather than tools. I'm going to talk a little bit about Python, but not that much, because as you've already seen in this class, tools come and go, programming languages come and go, concepts don't. So putting people first, that concept and what we mean by that, we're going to unpack it as we go, that doesn't change as the interfaces come and go. So we're going to spend a lot of time emphasizing concepts, and I'll draw examples from Leap Motion and web pages and other places as we go. But most of the tech that we're going to talk about in class is just there to serve as an example of the concepts. So listen for that. I'm not expecting you to memorize every interactive system we talk about, but I am expecting you to take away from that example why we're focusing on this particular concept. Okay, now the good part. We've got through all the housekeeping. Any questions? Yes, sir.
Is there a quiz tonight?
There is a quiz tonight, that's right. It's on Blackboard. Maybe it's worth me just showing you where. Let's see, Blackboard. Okay, so if you go to course materials, everything to do with the project and the deliverables is in here. Everything, all the lecture slides, everything to do with classes is in here. Tests are in here. So this item is not available. It will be available at 5:45 p.m., I think, right after class. If you click on that, it's a short quiz in Blackboard with 1 or 2 questions, not about the housekeeping issues, but the stuff we're going to talk about from now until 5:30. Okay. Any other questions? Okay. Okay, so let's talk about the why first rather than the how of HCI. So why bother taking this class instead of all the other great CS classes that we have on offer? One reason is there's a lot of money to be made. Let's start with the most practical and obvious one. As probably you all know right now, computer programming jobs are booming. Companies can't hire enough good programmers. They can't hire enough good programmers. They can't hire enough good programmers that are thinking carefully about the user. There's still some interesting back-end internal algorithmic jobs, but they are in the minority. The majority of interesting jobs that are out there, high-paying, interesting computer jobs, are people who know how to make good websites that have good interaction, that can demonstrate they know how to write an educational game for Leap Motion. That kind of thing, that left brain and right brain thinking is what a lot of companies are looking for. This is just a snapshot from CNN that ranked the best jobs a few years back. Unfortunately, Humboldt College professors only ranked number 2. This is a snapshot from a few years ago. Just for fun, I looked this morning, and college professor isn't even on the list of top jobs anymore. So that makes me a little bit nervous. Anyways, software engineering, computer programmers, they're always at the top of the list. Okay, aside from interesting creative jobs that pay well, why else might you want to pursue a career in HCI? It's revolutionizing the world, right? As we know, computers are revolutionizing the world, but now interfaces, right? The software on top of those computers are what's really revolutionizing things. I apologize for this screen. Let's see if it's better if I turn off the light here. Is that any better? Not really, yeah? Okay, let me see if there's anything quick I can do here. Okay, we'll suffer through this. Okay, second reason why is we're going to spend a lot of time in this class talking about design and visual design, right? We're all drowning in data and information and visualizations. We're going to spend a lot of time talking about if you have a user that's continuously interacting with your system, what should you be showing them at any given time? And it sounds like kind of an obvious question on the surface, but it turns out to be very difficult to do in practice. Here's a particular visualization that I pulled off of the Gapminder site. It's hard to see here, Gapminder all in one word. You can go and play around with Gapminder at your leisure. It's a great interactive website. As I mentioned, I'm going to draw a lot of examples from Leap Motion for hardware, and I'm going to draw a lot of examples from Gapminder for software. Gapminder embodies one of the most important lessons of visual design, which is maximize the amount of information displayed with a minimum of ink. So in the old days it was ink, now you can think of with a minimum of colored pixels. In the Gapminder interface, pretty much every pixel here is doing useful work. You know that this is a good interface if you can learn a lot from this visualization without having to go and read the help pages or go and read the legend about what is what. So some of the sidebars here give you a little bit of information, but let's focus for the moment, just for the sake of argument, on this plot itself. What is this plot telling you? Let's very quickly try and pull out all of the relevant information here. What is the information being conveyed here?
Positive income and life expectancy have a somewhat positive correlation.
Okay, so we have gross national product down here, basically income per capita, how much an average person takes home per year, and on the vertical axis, life expectancy. So one axis is wealth, and the other axis is health, and as Eric pointed out, there's a bit of a positive correlation here. So for dots tend to appear along this line. So the wealthier your country is, generally speaking, the healthier your country is as well, right? Not surprising. All right, I've already given away part of the punchline, which is that every dot here represents a country. Not all the dots are labeled. How do you know which dot corresponds to which country? Sorry? Aha, right. So if you launched the Gapminder site or something similar and everyone was hovering over your dots to figure out what the dots represented, you failed, right? Like I said, we don't want to be going to web pages or hovering over things for more information. The way you present information should suggest its function, right? So in a good design, in Gapminder, for most people, they don't bother hovering over the dots. Most of them you can sort of figure out, not all of them. You want to see how few people hover over the dots. So that's a great example. So obviously, the yellow dots there that are aligned in a trajectory, that's the United States, and the big red dot is China. I apologize, it's hard to see what's the big light blue dot here. Sorry? India. Yep, it's India, right? Again, it's hard to see. Unfortunately, there are a large number of dark blue dots in the lower left. What does that represent? Sub-Saharan Africa, right? If you look carefully at the world map in the top right there, you'll see Africa is divided into blue and green. And unfortunately, because of the projector, we probably can't go much further than that. Right? So color obviously represents which region of the world it comes from. What does the size of a dot represent? Doesn't actually say on the interface here. How did you know that? Absolutely, right? So I just assumed, right? You had a prediction based on a quick glance at this, right? This is, again, a very important part of HCI design. When you immediately present visual information or auditory information to your user, they're going to immediately start making predictions. We're going to spend a lot of time talking about human psychology and the brain. The brain is a prediction machine. The moment it starts to interpret this, it's going to start making assumptions or predictions, right? Maybe the size represents something to do with location in the world. Nope, that's not true. Color tells me where in the world that country is. Maybe size says something about population. How do I know whether my assumption is correct? You actually said it, right? You verify your prediction. And how did you verify your prediction in this case? Right, so you know the population of China is larger than the population of the United States. Given that prior information, you can see that the red circles are larger than the yellow circles, probably holds up. Why does a larger circle correspond to bigger population? Why don't you make the circle bigger the smaller the population is in that country? People take up space, right? It sounds like kind of a ridiculous question. Of course, bigger circles should represent bigger population, right? Again, it seems obvious in retrospect, but that's an example of, again, something we're going to talk about in this class, which is visual metaphors, right? All you're seeing here are colored dots, but they're telling you information through a metaphor of things that are not immediately at hand, like population or the fact that people take up space. There's a metaphor there, right? The bigger the circle, the more people you could put in the circle or what have you. So one visual metaphor that you can see here is that size of the circle correlates with size of population. There are many other visual metaphors that are hidden in Gapminder. Who can give me one more? What's another visual metaphor here? Something about the way this visualization is created that gives you more information. Yes? Absolutely. So you're sitting in the back and you are occluded by other people that are in front of you, right? So students that are further away from me in the class tend to be more occluded than people that are closer to me in the class. You all have decades of experience with this situation. Your brain knows that things that are farther away are more likely to be occluded than something that's close to you. That's something you've just learned over time, right? This visualization exploits that fact, right? So some of these circles correspond to the health and wealth of China in the 70s, 80s, 90s, and 2000s. I apologize here, but this snapshot here is actually representing the state of play in 2004. So this trajectory is showing you change in health and wealth in China from 1975 to 2004, and same thing for the United States. Nothing on this interface is telling you, except maybe the hint about where the label is placed, that China in 1975 is the one that's at the bottom left that's mostly occluded by the others, and the China that's not occluded corresponds to 2004, right? The state of China in 1975 is further away from us than the state of China in 2004. It's a second visual metaphor, which is now playing on time, not space or volume. So again, to build up your intuition about what this class is all about, as optional homework, see how many visual metaphors you can find in the Gapminder website. Okay, so again, creating interfaces, liberating data, being able to present information to people in useful ways, as we can tell in the last few years, is going a long way to changing the way people learn about their world. And once you start to learn things from visualizations, you can now start to change things. Here's another screenshot that I took from Gapminder. What is being shown here? Why did I pick this particular visualization? Okay, so for those of you who can't see, the horizontal axis there is fertility rate, the number of children per woman, and life expectancy, a different health indicator is plotted on the vertical axis here. What happened in China in the last 50 years? The one-child policy. When did the one-child policy happen? And I'm not putting you on the spot because if you read the visualization, you should be able to infer roughly when it occurred. And again, it's not written here, right? You're not hovering over something to be told the date at which the one-child policy was instituted. Why do you think it's 1964? 60, 61, 62, 63. It's a little hard to see here. Maybe this was 63, 64, right? So yes, mid-60s, in different places, different times. And you can see the impact of what happened. Did the one-child policy, so again, let's try and use this visualization to deduce things about health and wealth relationships in various countries. Did the one-child policy work? What was the goal? Obviously to control over population, but why? Why control over population?
Resources are limited.
Resources are limited, okay. So if it worked, you're maybe not using up all your resources. How would that show up in this particular system?
Well, if you have resources to live on, then you're living higher.
Okay.
So you have a higher life expectancy.
Okay, is that true?
Yes.
What tells you that?
As the dots go up
Yep.
through time.
Okay, so did the dots start going up faster after the one-child policy? No. So life expectancy in 1960, a little more than 35 years. In the couple years leading up to the one-child policy, things were getting a lot healthier in China, if you go by life expectancy. And again, that's a bit of a leap. Right? So the rate of increase, or the rate in change of height of these dots before the one-child policy looks to me equal to or greater than the rate of increase in life expectancy after the one-child policy.
Yeah, but we all die. It's not like just if you're infinitely healthy, you're never going to die.
That's true, right? So there's lots of things that are not shown here. This is the average life expectancy, right? We could unpack average life expectancy, and it might be that life expectancy went up for the poor, the most worse off, but not for others that already had a long life expectancy. So this is clearly not going to resolve the issue of the efficacy of the one-child policy, but we can use it to start to ask those questions, right? So one thing you can do on Gapminder is click on some of these axes and replace them with a different health or wealth indicator, right? So again, like we did before, you have a hypothesis. Did the one-child policy help or not? And you can try and verify or disprove that hypothesis pretty quickly by swapping in and out different indicators. So the rate at which you can start to investigate relationships between health and wealth is greatly accelerated by this particular interface, which is exactly what it was designed for, right? So I'm not an expert in health and wealth indicators, but even a naive person like myself can sit down and play with the data and explore different hypotheses, right? people are empowered by interfaces like this. This is one way that HCI can help. And again, we're going to spend a lot of time talking about visual design later in the class. Okay, third reason why HCI is important is that interaction with computers is everywhere, it's ubiquitous, and it's all the time. It's continuous. We used to play a game in this class, and I don't think we're going to have time to play it today. It's called the CPU game, which is where you make a guess about how many CPUs are in this room. And for simplicity's sake, we'll assume that if you have a laptop, there's one CPU, which again is an oversimplification. We're not going to play that game today, but when I started playing this game in 2006, the students were great at predicting how many CPUs were in the room. They were usually off by 2 or 3 CPUs. If we played that game today, we'd probably do pretty bad at guessing. Right? How many CPUs on average do you think each of us is carrying around? At least 2. Right? 4, no, 6. It gets harder and harder to know every year because we've got more and more smartphones and iPods and laptops and leap motion devices. This was the trick part of the question, by the way. There's 35 CPUs sitting right up here. Good technology, if it survives long enough in the market, is ubiquitous, right? Most of us have one version of this or another in our back pocket. And it's continuous. How many of you have your cell phones turned on right now? How many of you have your ringers turned on? Excellent, good, okay. So some of you are probably communicating with your phone by feeling vibrations or what have you, or obviously interacting with technology by looking at your laptop screens and so on, right? These days, it seems normal that we're continuously interacting with technology, and most of it is, thank goodness, hidden in the background. Okay, so here's my little cartoon to kind of show where we were and where we're going. So not in the not too distant past, there were a whole bunch of humans represented by H. A very small, fortunate minority of those humans had a computer, and a very, very small fraction of those people had phones. These days, most people have a computer, most people have phones. And again, I apologize for this. Here's 2 more Gapminder plots that show something about the relationship between computer ownership and phone ownership. So in the interest of time, I'll just walk you through this. This is reporting the number of personal computers per 100 people versus life expectancy, so something about the relationship between ownership of technology and health indicators. Number of cell phones owned per 100 people plotted against life expectancy, and this data is for 2006. You can see that even back in 2006, most people all over the world owned more cell phones than they did computers. It may be difficult to see in this plot, but there are some countries where people have on average 2, 3, or 4, or 5 phones. I don't know how that's possible, but there you go. You can go and explore that at your leisure. Okay, so these things are rapidly overtaking these things. And was that something that people saw coming? Probably not, but again, it has to do with the very fundamental different interactions between this thing and this thing. Okay, so where are we headed? Just to add to this cartoon here, in this class, we're going to break our discussion of interactive technologies into 3 classes. We're going to talk about computers and cell phones and all the things that you're most familiar with. The second class of technology, we're going to talk about our embedded devices. So these are devices that are physically implanted in the world. They're on most of the time, and they're sensing stuff that's in some radius. So that's the big circle here. If you go over to the Davis Center, there are embedded devices in most rooms that detect lack of motion, and if there's lack of motion, the lights in the room will go off. You're an HCI programmer, you're writing software for intelligent light sensors. What could possibly go wrong? Exactly, right? So if we're all in the Davis Center and we all kept very still for a while, the lights would go off, right? Even in a simple embedded technology like that, there are HCI issues you need to think about. Okay. So let's continue on. We already have drones. We're moving towards having robots deployed in our everyday world. robots obviously are very cool, but they are nothing more than a walking and sensing computer. Right? So like an embedded device, a robot is sensing stuff happening all around it. The difference between a robot and an embedded device is that the robot can move itself, or someone can easily move the robot. So what happens in a couple of years from now when this is the state of play in most developed countries? What kinds of software should we be writing for this incredibly networked and interconnected system? So I want you to think about these cartoons as we go forward through this class. And again, we're thinking about what are some of the upcoming challenges in designing for these kinds of technologies. So far, so good? Okay, so I'll just continue for another 5 minutes, and then we'll collect the lead motion devices. Again, just a note about the tests. Here's a good way to do things on the day of class. Before class, download or print out your lecture slides. As I mentioned, annotate them along the way. You might want to do the assigned reading before class. During class, annotate your electronic or paper version of your slides. Not in this set, but in the next set of lecture slides as we go forward, you're going to see that I put big red boxes, and those red boxes are empty in your version of the slides, and they'll be filled in on my versions of the slide. Those red boxes there are, again, a prompt for you to fill in those red boxes and make sure to annotate your slides. I'm sure you've all taken classes where you get the whole set of PowerPoints before, and everybody's eyes glaze over as the course goes on, right? So stay with me. Okay. Let's see. After class, finish up the reading, go over your notes, then go do the homework. As I mentioned, when we finish class, the homework will be due on Blackboard at 11:59 p.m. that night. Okay. Any other questions? I was going to go through the schedule, but I think I will start with that next time. So before you get up from your seats, what you're going to do is you're going to come up and collect a lead motion device. On the box, you'll see a number. On the box, you'll see a number. Sign your name next to the number here, and you're in charge of that lead motion device. As I mentioned, I need 5 pairs of students to share 5 lead motion devices, at least for the first week or two. So if you know someone in the class, please sign up together. Okay, thanks very much, and we'll see you on Thursday. Doesn't matter which one you grab, go ahead and open it. It's not a very good interface. Where's the sheet?
Yeah,
Sheet's right there.
That's where I'm now, so it's all like remote kind of communication. It's been really good. It's been busy at least.
Thank you very much.
You want me to send it out for both of us then?